Hello, my name is Jon Rittgers and currently work as a product technology development engineer. My primary role is System Reliability Expert Lead with Hewlett-Packard Inc. in the Thermal Inkjet Supplies Group. Today I would like to talk about the role of system reliability with respect to new product development. In this slide deck, I will talk about a typical development process in relation to reliability. What reliability process basics are and can be meaningful to be successful, and what the benefits of using reliability basics from the start of a program and what it can bring. But why is it important? The expectation of any business is that any new product development program has an expectation as an output, but issues need to be found early in order to address them through design changes or process improvements. Risk can be exposed both to the organization as well as to the product itself and its success in the field. When failures are understood and severity can be quantified, you can move forward. Resource utilization is a very important element within system reliability, as in order to address the defects, you need people, time, and materials. Once you release the product, there's going to be an expectation as to what the reliability will be. However, if it's lower than expected, the return on investment, which is key to a company, will be hampered. It will impact sales, warranty, company image, and eventually profit. This is a typical product development with checkpoints or stage gates as you go through from concept to the market. The correct development team needs to be put in place in order to define what the actual product needs to look like, what determines a successful product, and the metrics they're going to use to measure the performance of the product. However, there are different ways of developing a product through rigid checkpoints, which is linear. Nothing gets through unless it actually is completed 100% before the next phase. This actually can delay the amount of time it takes to get a product to market because not all areas will be in sync to that level. Flexible checkpoints, or a smooth flow, allows for exceptions. Areas need to be reviewed in order to be completed. However, there might be something that's not quite finished that will actually not impact the end game or be able to be understood enough to move forward. Permeable checkpoints, on the other hand, the various areas will work independently of each other, and this will cause potentially more cost and potentially less interaction between the areas because they're now in a siloed type of development cycle. This isn't a recommended method for most hardware type products or device type products. It might work better in a software type of environment. Once it is clear the type of new product development cycle checkpoint process to be used, the program team needs to turn its attention to metrics and measures. In this case, it's setting up the system reliability goals for usage, time, and acceptable warranty. This is different for every product depending on the marketplace. With this information, each checkpoint can then be objectively measured as you move forward through the process using actual data to determine how to proceed, not just whims and fancies. Once the testing is complete for each fail mode, the overall system reliability can be calculated and modeled for the final warranty assessment. This ultimately will show how good or bad you expect the return on investment to be. Will you have a large warranty bill, or will you make a lot of profit? It's worth noting that for each checkpoint, the system reliability level should be increasing due to the fact that the design, the processes, and the product itself as a system become more stable, and eventually we get to the final goal at the final checkpoint. Now, how are these goals determined? How do you go about figuring out what is good, what is bad? Much of the time it's using models. In this case, I've used in the past, and I'm currently using, Monte Carlo based models where various inputs are ran to generate a curve. And these curves would determine what is good and what is bad over time, or in this case, usage. In this case, what we're looking at is the number of cycles as you go along the x-axis, and this percentage on the y-axis is determining what type of customer would go to that particular cycle. Our most valued customers tend to be in this top 30%, above 70% essentially, where the target of 85 percentile is our midpoint of the most valued customer segment. In this particular case, because we are talking about inkjet, this would be entailing printing, and the number of pages that are actually printed tend to be in this small quartile of customers. 80% of pages are printed in this green zone, as opposed to 20% of the pages are down below. To determine what the time goal would be is a trade-off, essentially, between what you're determining to be useful life of the product versus excessive failures in the field and warranty. In this case, the product life will start to turn about this point, which is approximately 30%. And that trade-off generates this curve. In this case, we're looking at a 5-year time frame that balances between a fall off in performance where, rather than retiring the product, failures take over the product. This balancing effect determines where you will be in the time sequence. But how do you actually go about determining the goals and for each subsystem? As you go forward, you can actually see that it's a cascade, in this case a serial subsystem, which uses a simple power to determine what reliability will be. The nth reliability failure mode or subsystem determines what the actual percentage will be. In this case, we have both usage and time residing within the system. The overall product goal in this case was to meet 90% reliability. For usage, it was 55,000 cycles. In time, it was 5 years. By knowing this and knowing the number of subsystems, you can determine what the next level reliability needs to be. In this case, there's 5 subsystems, so hence each subsystem needs to achieve 97.9% reliability to move forward. Or, if you talk in pages or cycles as the case is, at 90% reliability, you would need to achieve 94,000 cycles. This is just a simple layout of what a cascade reliability goal set up for subsystems would look like. Let's do a simple example on how you would calculate the actual value with data. In this case, we'll use the time base, which has a simplified system with the product system and the subsystem both being within a single system, so hence the cascade of 3 elements is used. In this case, we'll look at 96.5% for each subsystem would be the goal if uniformly distributed. Until you have data, uniform distributions of reliability are typical. In this case, we'll say the system has 5 fail modes, and hence the uniform distributed goal of 99.3% for each fail mode. As we look at this, there might be data saying that we have good reliability with 99.97, 99.5, and 99.9%. However, there are 2 fail modes that are not achieving the goal of 99.3. One is at 98.9, the other 85.6. When it's all calculated, 84.1% would be the cascade effect of these serial fail modes. So hence, for your subsystem 1, there are 3 values, 96.5, 96.5 because they achieve the goal level that's desired, and 1 at 84.1. When you calculate the final reliability of the subsystems, it comes out at 78%. Subsystem 1 is the only time-based system in this case, and it misses the goal by 12%. Not very good for a final output, and would have impact on the warranty without doubt. But this depends upon when it was actually found. If this was found early in the process, design corrections could go into place and be tested again to improve that reliability. In summary, there are several sections that need to be addressed as you go through a development cycle. And with respect to system reliability, you're looking at the method of the design cycle to determine how important or how weighty the various goals will be. A rigid system, a flexible system, a permeable system for developing the product determines much of how you react as a program. The program team needs to be the decision makers, the people that can actually decide whether to move forward or not. They have to agree on what is a good goal and a bad goal, what is acceptable or what is not acceptable. And once they go through the checkpoint, they need to verify that everybody is in agreement. System reliability has to have appropriate goals. You can model the system to determine the goals, but it always comes back to the real data. Subsystem goals are constantly improving, and it's a means of tracking the performance of the system overall. The final reliability assessment helps determine what the warranty might be. It doesn't calculate exactly what it will be, but it gives the business an idea of what kind of bill they might expect. Again, system reliability in terms of product development is key. It's been used successfully in many of the projects that I've been working on. If you would like to know more about myself and what I do, you can find me on LinkedIn through the link here. Thank you very much.